Alright, this is just going to be a quick demo video. Someone on a chat channel I'm on was looking into hooking Windows API functions, and I think he ended up doing it with mhook or one of these other hooking libraries. And I suggested that for prototyping, it's sometimes useful to do it more interactively with a disassembler. And I thought I would show how you can do it with Cheat Engine, which, despite the name, is a really capable low-level assembler. So here we have a program, and this is obviously just a dummy program. So I call the function that he was calling in his program, but I have a get char just so we can easily hook the process. For permanent deployment, you would probably do something else. But anyway, so you run it, it waits for a key, and then executes the empty working set. So right now it doesn't do anything visible. It does empty it, but it doesn't show anything else. So let's change that. So let's run it again. So it's running here. And then let's start Cheat Engine. And I'm going to attach to that program. I'm going to bring up the memory view. And there's a bunch of different ways you can sort of find points of, kind of ways to attach yourself or hook yourself. But in this case, since we want to hook an API function, let's use the enumerate DLLs and symbols window. And the function we're looking for is in here. And so if we double click on this, we will go to the import shim for this thing we're interested in. So I'm just going to leave that there. So let's say we want to, so let's just say this. Let's say we take this instruction and we use the auto assembler with a standard template. And so what it does is it allocates 2K of memory in the remote process. It creates a bunch of labels. One of the labels has a copy of the original instruction, so we're going to do that after we do our new stuff. And then we're going to insert some stuff here that's labeled new mem. And then after this is done, it jumps back to the original call site. And then finally, you can see here it patches the original instruction in place to jump to our special code. So let's say we want to do a message box A to show a message box. In this case, it just happens that we don't have any code that loads user32.dll, so we have to load that ourselves first. And this is also how you would load your own DLLs for any kind of code injection. So user32, we don't want to execute a function because we just want it loaded into the address space. And so now that it's loaded, we can call it. And so we just have to, this is 32-bit x86, so I think we have to do something like this. And then the title and text are pointers. Let me just, I'm just looking on MSDN to see what the argument order is for message box. So text, caption, type. Okay, so that is the right order. Right, so in order to actually push those my title and my text pointers, we need those strings to live somewhere. Since we're already allocating a 2K segment, we will just put them right after the code snippet. And so my title will be, let's just put in an alternate string. So I think that's it. And then we try to assemble and execute it, and it successfully assembles, and now it wants to inject it. So it's now injected, and if we go back to our program and press enter to get past the get char, we will, this popped up on my other monitor, we will get this thing. So that's how easy it is to do this kind of thing.